I'm in the privileged position to rarely think about where my water comes from. I turn on the tap and water comes out. It's clean and it's plentiful. But for many people around the world, this is not the case. And adding to this, for most of us in cities, the source of our water is not always clear. Today's video is on water access and its relationship to development planning. It goes without saying that access to enough drinkable water is existentially important for all people. The UNDP acknowledges this in its Sustainable Development Goals, dedicating Goal 6 to ensure the availability and sustainable management of water and sanitation for all. The aim of SDG 6 is not just drinkable water, but access to the associated services and hygiene. It's here that I would like to mention that while sanitation and water access are deeply entwined, going forwards in this video, we'll be focusing solely on water access. I'll also note at the top that the topic of water access links to a number of other concepts discussed in this course, including gender, urban growth, informality, inequality, corruption, governance, and the right to the city. Some will be explicitly mentioned in this video, while others will be implicitly mentioned. Mexico City provides us a great illustration of our complex relationship to water. Some of the historical context of the city was discussed in the introductory video, but just as a reminder, Tenochtitlan, the Aztec city, was built on a number of islands in a great lake that sat at the center of the Valley of Mexico Basin. The city was destroyed by the Spanish conquerors, and Mexico City was founded. Eventually, the lake was drained, and today, Mexico City sprawls across what was once lakebed. In more contemporary times, Mexico City has experienced explosive population growth, specifically over the last century. The population today is well over 21 million people, and it's one of the largest cities in the world. All these people and all this industry requires a lot of water, and this is a central challenge of the city. According to the Ministry of the Environment, over 97% of Mexico City's households have access to piped water, and the average water use in Mexico City is 320 litres per person per day. But these statistics hide some worrying characteristics of water access and use in the city. While it is true that the vast majority of households have a connection to piped water, this doesn't mean that the water is always running. There are areas in the city where water runs sporadically, just a couple of times a week. And also, that number of 2% of households that are not connected to piped water, in Mexico City, 2% of households equates to almost 50,000 households. That's hundreds of thousands of people. I'd also think that we need to talk about that figure of 320 litres per person per day. The first thing to note is that it's kind of shockingly high. For comparison, it's almost double the average water consumption of someone in southeast Queensland, which, to note, for the month of December 2022, was 168 litres per person per day. It's also well above the UN's recommendation of 50 to 100 litres per person per day. The figure is probably artificially high. About 30 to 45% of Mexico City's water is estimated to be lost due to pipe leakages. But really the central thing to note is that 320 litres a day is an average. Water access is extremely unequal in Mexico City, and it reflects the city's unequal socioeconomic landscape. Some of the city's wealthiest neighbourhoods have average water uses of 700 litres per person per day, while some of the poorer neighbourhoods, often those that are informal and found on the city's urban fringes, have average uses of water of less than 20 litres per person per day. That is a difference of 35 times. This is one way we can see how water access is linked to inequality, informality, and urban growth in the city. Turning to the source of water supply for Mexico City, we can see more complexity. Around 66% of the city's water comes from groundwater extracted from aquifers in the Valley of Mexico Basin. The intensive extraction of aquifers began in the mid-19th century, and since then, the groundwater in the Mexico City Basin has dropped by more than 80 meters. Extraction is now so great that the water table is dropping by about a meter a year. It has also resulted in parts of the city literally sinking, some areas up to 40 centimeters a year, and this has serious implications for the structural integrities of buildings, specifically during earthquakes. See our video on corruption in Mexico City for more information. But the rate of aquifer depletion would be far worse, except municipal, state, and federal governments have embarked on a number of projects to pipe water in from outside the Valley of Mexico. These projects are expensive and they are complex engineering works designed to move water from hundreds of kilometers away and over mountainous terrain. One such system pipes water in from over 200 kilometers away, and the literature tells me it's one of the largest and longest urban water supply systems in the world, while another pumps water up by more than 1,000 meters of altitude to get to the city. These projects are extremely expensive, they're energy consumptive, and they are currently only partial solutions to the water problems faced by the city. With all this, they only contribute 33% of the city's water. And it also means that water is being diverted from elsewhere in the country, and it's increasing water scarcity elsewhere outside of the Valley of Mexico Basin. It's also likely, though, that these kinds of complex and expensive engineering works will become more common in the future and will become a greater part of the city's water supply. Because at current rates, the aquifers that the city relies upon are predicted to run completely dry by 2060. The city is depleting the aquifer's water faster than it can be recharged. And this is because as the city's experienced urban growth, hard, non-porous surfaces have been built. So we're thinking concrete, bitumen, those kinds of things. And this stops water from seeping into the ground. As water consumption has increased, aquifer replenishment has decreased. And this has left just a single large ecological preservation area to the city's southwest. So kind of like a national park. And it provides virtually all of the replenishment of the city's ailing aquifers. The ecological preservation zone covers around 90,000 hectares and it's officially protected from development, but loss of the smallest amount of preservation zone is highly detrimental to aquifer replenishment. Every square meter lost is a loss of 2,000 to 2,500 litres of water from the aquifers a year. Sadly, a study in 2011 cited that close to 500 hectares of preservation zone were being lost to deforestation for informal settlements and the associated agricultural expansion every year. This issue has unfortunately positioned the urban poor and environmental conservation in opposition. The state solution has generally been just to grant land tenure and legal status to these settlements, but this comes with the cost of the city's future water supply. We're really only scratching the surface of water in Mexico City, and I think it's already becoming very clear that it is a really complex challenge. It also illustrates the balancing acts that play out in development planning. Similar challenges are playing out around the world in other cities regarding water. And as I said at the start, if we understand how deeply important water is to us, I think we can all see what an imperative it is that we find a solution to challenges like this too.